Okay, so the goal is to predict the net hourly electrical energy output using several features which is given in the dataset provided. For modeling, I have used random forest algorithm for the regression task. Random forest is an ensemble learning method that builds multiple decision trees and combines their predictions to improve accuracy and reduce overfitting. For preparing the data, this is where the data is being loaded from the Excel to using the read Excel package. These are the commands which helps provide a preview of the dataset and summary statistics, which helps in understanding the data distribution and identifying potential issues. For splitting the data into training, which is 80%, and testing, which is 20%, the create data partition, which is here, the create data partition function from the caret package is used, which ensures a stratified split based on the target variable. For building the model, as previously told, we have used a random forest model. So for cross validation, the model's performance is further evaluated using 5 cross validation. This technique helps estimate the model's accuracy by training and validating the models on different subsets of training data. This is the cross validation part. We have print RF model and print CV model. The model summary provides details about the trained random forest model, including the number of trees, variable importance, and cross validation results. For predictions, for the prediction part, the trained model is used to predict PE on the test dataset. These predictions are stored in test PRED, line number 29, test PRED. And for calculating errors, we use the root mean square error. Lower RMSE indicates better model performance. Model visualization, we have four major categories of graphs. First one is histogram, second one are the scatter plots, third one is the predicted versus actual plot, and the fourth plot is a residual plot. The histogram visualizes the distribution of target variable in training data and helping to understand its range and central tendency. So here you can see the histogram. This is the histogram. This is the frequency, net hourly energy, output. So this is the first type of graph. The second type of graph is the scatter plots, which is each feature against the PE. So this is, let me show you. This is scatter plot of AT, ambient temperature versus PE, scatter plot of V versus PE, scatter plot of AP versus PE, and scatter plot of RH versus PE. Yes, these are the 4 types of scatter plots. This is the graph for predicted versus actual PE, where the predicted PE is on the y-axis, and on the x-axis we have actual PE. The red line is a solid 45 degrees angle line, and majorly we have points scattered around a red line, which shows the model is fairly good. And the fourth one is the residual plot. The residual plot shows the difference between the actual and the predicted PE values. Ideally, residuals should be randomly scattered around 0, indicating no systematic error in the model predictions. The result part, the console part, let me show that also. This is the okay. This is the summary, the minimum, first, median, mean, maximum. This is the data AT, V, AP, RH, and then this is the random forest. Number of trees is 500, and number of variables tried at each split is 1. Number of square residues is 11, and percentage variable excellence 96%. And after that, we have 7,656 samples for predictors. This is the RMSE value, the R-square value, and ME value. The final value used for the model was MTRY2. In conclusion, we can say that this code successfully trains and evaluates a random forest model to predict net hourly electrical energy output. The RMSE metric and various visualizations provide insight into model's accuracy and areas where it may need improvement. The cross-validation step ensures that the model's performance is robust and generalizable. Thank you.